Welcome to our Embedded Systems project video, the Voice-Controlled Robotic Car, or Voco for short. First, a quick breakdown of embedded systems. An embedded system consists of four main components: sensors, which generate signals for the system; hardware, which interfaces with the various parts of the system; software, which provides control over hardware to refine input and produce output; and actuators, which reacts to the conditions. Together, these four components combine to form a system designed for an application or purpose. In our case, the Voco is an embedded system designed to control a robotic vehicle using voice commands. The main sensor for our system is the EasyVR3. This module provides an abstracted solution to the voice recognition. Some aspects of this module are: it supports 32 user commands, it operates at 3.3 or 5 volts, it has 6 general-purpose I/O pins, communication is done via UART at 9600 beats per second using 8-bit data, no parity bits, and 1-stop bit, and it can be programmed using the provided EasyVR commander to load custom commands. Programming the module can be made relatively more easier through the use of the EasyVR Arduino libraries. Now, the main hardware component is the ChipKit DP32 prototyping board by Digilent. It comes with a PIC32MX, which is a 32-bit microprocessor. The device has an 8 MHz clock frequency, which can be increased up to 40 MHz through the phase lock loop system. There are 128 kilobytes of programmable flash memory and 32 kilobytes of RAM memory. General-purpose I/O pins are used to interface with EasyVR and the motor controller. The Arduino compatibility was of aid during this project, as it allowed for use of readily available libraries for the EasyVR. The second hardware component is a motor controller, the L293D. This integrated circuit acts as an interface between the microcontroller and DC motors. There are 4 half-bridge drivers that allow for output of 4 currents, 2 pairs of bidirectional current, each up to 600 milliamps at voltage levels between 4.5 and 36 volts. This allows for forward and backward movement of each wheel, which gives us the range of the 4 movements we require. This controller is necessary to control the motor, as they cannot be connected directly to the microcontroller pins. We have chosen this alternative to PWM because the motors were not designed for use with PWM signals. The motors in this project are the actuators. The ones used in the Voco are the FM90 DC motors. These are not servo motors, they are micro motors. Operation is done via a motor controller. They are designed to work similarly to a brushed DC motor. The working range under load is 550 milliamps to 650 milliamps between 4.8 volts to 6 volts respectively. Here is a pseudo schematic for the Voco. Pins 3 and 4 on jumper 2 of the EasyVR are serial transmit and serial receiver respectively, while pins PB14 and PB6 on the DP32 are serial transmit and receiver respectively. Opposite transmitter-receiver pairs are connected for the UART communication. Additionally, pins 0, 1, 2 are used for left motor control, and pins 3, 7, and 8 are used for the right motor control as shown in the diagram. Of course, every embedded system has some software component. Here is a slight snippet of that component for this project, which was done via the Arduino IDE.
Forward, backward, right, left.
A major difficulty we faced was our inexperience with the supplied motors. Initially, the motors had burnt out, which resulted in project delay. One major improvement would be smoother navigation and control, i.e. continuous movement instead of interval-based movement. Another improvement would be to give voice commands remotely via Bluetooth or Wi-Fi. Adding tracking abilities so that the vehicle can follow an user would also be very useful.